Hi students, in this video I'll be going through the 2012 O-Level Additional Mathematics Paper 2 question 1. Alright, so let's take a look at the question. So the equation of a curve is y equals to 2 sine x minus 3 cosine x, where x is greater or equal to 0 and less than or equals to pi. Okay, so for part A, they just want us to find dy dx as well as d2y dx squared, right? So let's go ahead and differentiate. So y is equals to 2 sine x. So y equals to 2 sine x minus 3 cosine x. So dy over dx equals to, okay, so you differentiate 2 sine x, you end up with 2 cosine x. Right, then if you differentiate cosine x, you get negative sine x. Alright, so this one will simplify to 2 cosine x plus 3 sine x. Alright, so not difficult. Okay, so let's differentiate one more time to find the second derivative. Okay, so you differentiate 2 cosine x, you get 2 times negative sine x plus 3. Okay, differentiate sine x, you get cosine x. Right, so what we end up with will be negative 2 sine x plus 3 cosine x. Right, so this will be the answer for part A. Okay, let's take a look at part B. Right, so in part B, they want us to find the value of x for which the curve has a stationary point. So if you recall at the stationary point, the value of dy dx is going to be equals to 0, right? Because the gradient of the curve at a stationary point is 0, right? So let's do the working. So at the stationary point, the stationary point, right, dy over dx equals to 0. Okay, so dy over dx is 2 cosine x plus 3 sine x, right? Right, so 2 cosine x plus 3 sine x equals to 0. Okay, so if you recall, to solve a trigo equation, we always want to convert the whole trigo equation such that there's only one type of trigo function. So either sine, cosine, or tangent only. Okay, so now your objective should be to try to convert this particular trigo equation such that it only has one type of trigo function. So how can we do that? Okay, so if you think about it, you're definitely not going to use R formula for simple questions such as this, right? Okay, so what you can do is, if you think about it, if I bring the cosine to the other side, right? So what I want to do is I want to bring all the trigo functions to one side and all the numbers to another side, so that eventually I hope that I can get a trigo function equals to a certain ratio. Okay, then I'll be able to find the basic angle and solve. Okay, so notice that if you divide both sides by cosine, what you will get will be 3 sine x over cosine x equals to negative 2, right? Okay, so what we have done here is we have divided both sides by cosine x, right? Okay, to get rid of the cosine x on the right side. Okay, then if you notice that now at this point, sine x over cosine x is tangent x, right? So we will get 3 tangent x equals to negative 2. Okay, so tangent x will be negative 2/3. So once you arrive at this form, there's only one trigo function in the equation, which is tangent x now. And on the right side is a ratio, then you can solve the question already. Right, so let's find the basic angle. So let tangent alpha equals to 2/3. So in this case, alpha is the basic angle, okay? The basic angle. Okay, so alpha is the basic angle, okay? So alpha will be tangent inverse 2/3. Okay, so always remember when you find basic angle, you remove the negative sign, right? So alpha will be equals to, okay, now we are working in terms of radians. Okay, 0.5880, okay? Okay, so now we need to search the quadrant. So tangent is negative, so we will search the second and fourth quadrant, right? A, S, T, C. Okay, but if you look at the range, they only want us to search until pi only, 0 to pi. Okay, which is in the first and second quadrant only. So in this case for x, we will just get one answer. So x will be the answer in the second quadrant. So if you recall, if the basic angle is in the second quadrant, alpha is here, then the general angle will be pi minus alpha only. Okay, so pi minus alpha. Okay, so alpha is 0.5880. Okay, so this will give us 2.55 radians. Okay, so 363, right? Okay, so this will be the value of x for which the curve has a stationary point. Right, so not too difficult to solve. Okay, then in the final part, they want us to determine the nature of this stationary point. So to determine the nature of stationary point, we can either use the first derivative test or the second derivative test. But if you recall, for this question, we have already found the second derivative in the first part of the question. So I guess it will be easier to use the second derivative test, right? So let's sub x equals to 2.55 into the second derivative, and then we will see if it's negative or positive, and then conclude whether it's a maximum or minimum. All right, so when x equals to 2.55, right, the 2y over dx square is going to be equals to negative 2. Okay, the d2y dx square is negative 2 sine x, right? Okay, so 2.55, right, plus 3 cosine x, so cosine 2.55, right? So if you calculate this out, you will get negative 3.61. Okay, so this is less than 0. So if it's less than 0, then the curve should have a maximum point, okay, at x equals to 2.55. Okay, so we can conclude since d2y over dx square, okay, is less than 0, okay, the curve has a maximum point at x equals to 2.55, right? So based on answer key, okay, so it's a maximum point. Okay, so you can actually use the Desmos to actually plot out this curve, and then you see that when you find out x equals to 2.55, right? Okay, do we indeed have a maximum point? Okay, just to visualize your answer better, right?